Okay, so chapter 19 in your book moves to graphing rational functions, which we have looked at some. Rational functions are a polynomial over a polynomial. And so if you put this really carefully into your calculator, you may want to turn off the video and then come back. You're going to put that into y1, and then we're going to evaluate this numerically. So since we want to come from 5 plus, let's do y1 of, I did 5.01. I got it was like 1.6186 and a bunch of decimals. And then I did 5.001, and I got it was 1.6198 and a bunch of decimals. And then I did y1 of 5.0231, and I got it was like 1.61998. So it looks to me that this limit, if I had a guess, is about 1.62. Later on, we're going to find out how to do that without a calculator. Okay, well, let's look at the next one. And in fact, I think these are actually too small. So why don't you try doing like 150 and negative 150. And so if I do y1 of 150, I'm typing 2. I got 1.02. And if I do that with negative 150, I got 0.979 and a whole bunch of 9. So it looks to me like we're going to about 1. And we learned that last when we were looking back in chapter 13, because if you multiply out the numerator, your leading term at the ends, f of x is about equal to the leading term, which would be an x to the 4th over x to the 4th, which is 1. Okay, so we've got the limit as x goes to infinity of the function would be 1, which would be equal to the limit as x goes to negative infinity of f of x. And then we learned this unit, that tells us that we have a horizontal asymptote, y equals 1 for the function. Okay, now there's actually 2 vertical asymptotes here. It looks to me like there's one here. And how do you know that? Because you are approaching infinity. So if I just do 1, if I go from this direction, that's x is approaching 1 from the right. So the limit as x approaches 0 from the right of f of x is plus infinity. You guys know that the 3 dots mean therefore? Okay, so therefore y equals, and it's this number we're approaching 0, is a vertical asymptote.